Hi everyone, I am Kerem Savut. I'm a freshman student at the Department of Electrical and Electronics Engineering at Bilkent University, and today I'll present you my Phys101 lab project. The aim of my experiment is to determine the spring constant K with using the law of conservation of energy into several steps. The conservation of mechanical energy asserts that if only conservative forces are involved in a system, the total mechanical energy of a system neither increases nor decreases in any process. It means it's conserved. In our case, since there will be no friction or any other non-conservative force acting on the system, we can claim that total mechanical energy of the system is conserved. Since there will be only kinetic energy in the first position and only potential energy provided by the spring in the last position, we can show the equation as follows. Moreover, from this equation, spring constant K can be obtained by mv squared over x squared. Those are the equipments I'll use in the project. An air table with a spring attached to one side, a puck with a mass of 420 grams, a ruler to measure the speed of the puck before it contacts with the spring and to measure the maximum compression in the spring, and finally a scientific calculator to make required calculations. As you can see, I have also drawn a line which is passing through the points where the puck contacts with the spring to measure the compression amount in the spring more accurately. What I did in the experiment was to throw the mass towards the spring in the same direction as the spring. To do that, I have used ruler's direction to help me while throwing it in the same direction. To get more accurate results, I threw the puck several times at different velocities. This is the datasheet I have obtained after throwing the puck with 5 different velocities. Those are the graphs I have obtained after the experiment. The first table contains the velocity values calculated from the path that puck traveled in each time interval before it contacts the spring. In the second table, there are the values at which the same puck compresses the same spring at different velocities. As can be deduced from the formula, we observe that as the velocity increases, the amount of the compression in the spring also increases. This is the mv squared versus x squared graph of 5 different attempts. According to the formula I mentioned at the beginning, mv squared over x squared should give the spring constant value, which is the tangent value of the best line in this graph. From that calculation, I found the spring constant to be approximately 263.75 Newton over meter. Lastly, there is the error value of the found spring constant. There are two main reasons why this error occurred. First one is the throwing direction of the puck. No matter how much I try to throw the puck in an orderly manner, it is almost impossible to throw it in the same direction as the spring. A second reason is the spring is not completely in the same direction as the puck as a result of the angle it makes due to the air table. And these two reasons I mentioned cause the spring to vary in the amount of compression.